So in this video, I'm going to be showing you how to do empirical formula related calculations. The first question here is, you have a sample of a compound that contains 4.5 grams of carbon, 1.5 grams of hydrogen, and 4 grams of oxygen. What is the empirical formula of this compound? So they gave us carbon to be 4.5 grams, and then hydrogen 1.5 grams, oxygen 4 grams. Okay. Next step, divide each atom by their empirical masses in the periodic table. Carbon has 12.01 grams per mole. If we divide that, it gives us 0.375 mole. And then the next one, we divide by the mass of hydrogen. We have 1.5 divided by 1.008. That gives me 1.488 mole. We move on to that of oxygen. The mass of oxygen in the periodic table is 16 grams per mole. So 4 divided by 16 would give me 0.25 mole. So after that step, you're going to identify the smallest mole, and that happens to be 0.25. So I'm going to divide all through by 0.25. Divide all of these other values by 0.25. 0.25 being the simplest mole that we got. And the last step, so the first one, 0.375, divided by 0.25 will give us 1.5. 1.488 divided by 0.25 will give me 6 approximately. And then 0.25 divided by itself gives me 1. Now, whenever you have a 0.5, so if you have a 0.5, you multiply the whole thing by 2, okay? You cannot round up when it is 0.5. If you have a 0.33, a 0.66, you multiply the whole mole ratio by 3 if it was 0.33 or 0.66. Since what I have is a 0.5, I'm going to multiply this whole mole ratio by 2. This gives me 3. This gives me 12. While this gives me 2. Okay? That means that the empirical formula will be C3, H12, and O2. And that is how you calculate it. Now, the next question here says, a compound has an empirical formula of CH2O, and its molecular mass is 90 grams per mole. What is the molecular formula of this compound? When you have such question, the first step would be to find the empirical formula mass, which is the mass of this empirical formula they give us, okay? You have 1 carbon, multiply that by 12.01, which is the mass of carbon. You have 2 hydrogens, multiply that by 1.008, which is the mass of hydrogen. And then there is only 1 oxygen, multiplied by the mass of oxygen, which is that. Now 12.01 times 1 gives us exactly the same. 2 times 1.008 would be 2.016. And 16 times 1 is 16. Now if I add everything up, I'm going to have 30.026 grams per mole. So that is the empirical formula mass. The next step is to divide the molar mass that they gave us by this empirical formula mass. And when you do that, that gives us approximately 3, which means that the molecular formula is times 3 of this empirical formula that they gave us. So there's 1 carbon times 3, that is 3 carbons. Remember, these numbers will be the subscript, okay? Hydrogen, 2 times 3, that is 6. Oxygen times 3, that is 3. And this would be the molecular formula of this compound. The next question I have here says, a sample of copper 2 hydrate, which is that, weighs 6 grams before heating. After heating to remove the water, the anhydrous copper 2 sulfate weighs 4 grams. What is the value of X, the number of water molecule in the hydrate? This is the X. The hydrate is CuSO4.XH2O. And the total mass is 6 grams. Now, when a hydrate is heated for a long time, the water is driven off. And after that, this is going to be the one remaining, okay, because the water has been driven off. So the anhydrous copper 2 sulfate, the mass after water is removed, it's 4 grams, which means that the mass of water would be 6 minus 4, which is going to give us 2 grams. Okay, because if the total molecule weighs 6 grams and when water is removed, it remains 4 grams, it means that the mass of water is the change between the total and what remains. And that is 6 minus 4 to give us 2. So now we have the mass of copper 2 sulfate and the mass of water. We can then do the same steps that we did for others, but this time for the molecules and not atoms like we did before. The next step would be to find the molar mass of copper 2 sulfate and also the molar mass of water, and then divide these masses by their molar masses respectively. Okay, so we have copper, sulfur, and then oxygen. There is 1 copper multiplied by 63.55, which is the mass of copper. Sulfur, 1 times 32.06, and oxygen, 4 times 16. This is going to give me exactly the same value. This will give me exactly the same as well, but this one gives me 64 when you multiply 16 by 4. So at this point, I'm going to just sum them up. So 63.55 plus 32.06 plus 64, that gives me 159.61 grams per mole. So I'm going to go ahead and divide 4 by 159.61 grams per mole. And that gives 0.0251 mole. Now, I will do the same thing for water. For H2O, there is 2 hydrogens multiplied by 1.008. Oxygen, 1 times 16. This is going to give me 2.016 plus 16. That gives me 18.016 grams per mole. So the molar mass of water is 18.016 grams per mole. When we divide 2 by 18.016, that gives 0.111 mole approximately. So at this point, we compare the 2 moles. The smallest mole happens to be this one on top. I'm going to divide all through by that smallest mole, which is 0.0251 mole. And this is going to give me 1, while this gives 4 approximately. This simply means that the X value is 4. So the full empirical formula would be CuSO4.4H2O. And that's simply how you solve it.